Hey, fourth graders, welcome to Introduction to Geometry, pages 267 to 268 in your arithmetic book. All right, let's get started. So, just to give you a heads up, this lesson is going to be quite complicated. If you don't understand everything I'm saying, don't worry about it. This worksheet, it is quite easy, and I'm going to explain a lot of concepts, but it's going to be okay if you don't understand everything. But just try to pay attention and just I'll try my best to explain it clearly. All right. So first thing you would need to know is, what is geometry? Well, geometry is a kind of arithmetic that involves shapes. Okay, it's a type of mathematics, and in geometry you'll see questions like it'll show you a lot of times will involve shapes. All right, like a triangle, a rectangle. All right. So here's a triangle here, and it might ask you, let's see here. Let's say this side is 5. Let me see. 5 is to 5 feet. This side is 5 feet tall, and this bottom part of the triangle is 10 feet wide. All right. So a geometry question would ask you, if I know that this is 5 feet tall and this is 10 feet wide, how long is this side of the triangle here? Okay. That's an example of a geometry question you would see. Another example. Here's a rectangle here. Let's say this side is 4 feet. And the bottom here is, let's say 12 feet. All right. So another geometry question might ask you, how wide is A? Okay. Knowing that this base here is 12 feet wide, how long is A? Or might ask you, what is B? What about B? How tall? What's the length of B? Knowing that this side is 4 feet. All right. Those are some very simple geometry questions. So as you can see, geometry involves shapes. All right. Okay. So geometry is really important in lots of jobs, especially if you want to be an architect. They use geometry all the time when they're trying to decide how tall must they build a building, or even in space. If you want to be an astronaut, you will need to know a lot about geometry, and just like the angle of a rocket going into space, things like that. All right. Okay. So that's just the very basics of what is geometry. So there's just some really important ideas I need to introduce to you about geometry. First thing here, let's see, this little shape here. This is called a point. This is a point. All right. So a point in geometry is can be anywhere on the line. So here's my line here, and my point can be anywhere on here. So I can put a point at the ends of the line here. I can put it somewhere near in the center, or more on the sides. Okay, so all these green dots here, these are all points. All right, this is a point. And the next thing is, let's see, 2 points and with a line in the middle. This is called a segment, line segment. So line segments, you'll see a line, okay, and at the ends of the line you will see a point. All right. So line segment, it's part of the line. All right. And usually this point here tells me the line, it begins here, ends here, or it could be the other way around. It could begin here and end here, right? Yeah. All right. So there's something that's the opposite of a line segment. Let me show you. So instead of drawing 2 points, I'm drawing some arrows. Sorry. Some blue here. Okay. So this is called a line. All right. So I know it's kind of confusing. This is called a line. If you notice the biggest difference between a line and a line segment is line segments have a point and lines have these arrows, right? So, okay, what do these arrows mean? Well, these arrows tells me that this line here, when I see these arrows here, it tells me that this line keeps stretching out. It doesn't end here and here, unlike, my line segment. I know that my line segment ends here and ends here, right? This is as wide as it will be. But for a line with these arrows, this tells me it stretches on and on and on forever. There is no end. All right, so here's my line. If I have these arrows here, I know that this line can just keep going on and on and on, way past my white page here, and just keeps going, going. All right. Same thing about the other side here. With this arrow, it just tells me that my line here is just going to stretch out until forever. It will never end. Okay, so that's a big difference between a line and a line segment. For a line, it stretches out indefinitely, it never stops. But for a line segment, it stops at the points. Okay, it's a really important thing to take note. All right, let me erase all this. Okay. All right, so as a line. Next important thing you need to know is a ray. So a ray, it's a combination of both the line segment and the line. So I have a point at one end and a arrow at the other end. So this is called a ray, kind of like a ray gun. I don't know if some video games you might have like a ray gun or or even like a sunshine, right? Let me explain it. So a ray, it has a beginning. It begins here, and the line stretches on forever. Okay, because same thing with my line here. It has an arrow here at the end. So this arrow tells me that this line begins at the point, and it keeps going on and on and on forever. Okay, it'll never stop. So that is a ray. It has a beginning, but it has no end. All right, lines. It has no beginning and it has no end. It keeps stretching. And the line segment has a beginning, it has an end. All right, so that's some big differences you need to keep in mind. Okay. Next thing I need to tell you guys is something about angles. All right. So this concept might be a little bit difficult to understand. I'm gonna try my best to explain it, but I might not do a great job. If you guys don't understand this, do not worry. Abeka does not expect you to understand this. I don't really like the way Abeka teaches this. They just kind of throw it at you without explain what an angle is, but I'm going to try my best to explain it in a way that you can understand. So an angle is the amount of space between two lines that meet each other, how much a line has turned. All right. So really important part of this definition is the amount of space between two lines that meet each other. All right, so let's say I have a line here. Oops. Here's one line here. Okay, and I have another line. I'll put another line on top of it. All right, so I have two lines here. Let's say my orange line. I want to turn it up. I'm gonna have it turn a little bit. Okay. So the orange line started. It started on top of the green line, and you see how I turned it, kind of moved it upwards this way. So, sorry. So the amount of space here. Sorry, let me fix some stuff here. Okay, so this amount of space here, this space here, or how much it moved, that is the angle. All right. Okay. Sorry. So this angle here, I'm just gonna erase this. My orange line was like around here. Okay, so that angle here, the amount of space that moved, the amount of space that this orange line moved from here to up here. All right, that is the angle, and you would usually see for something that represents angle is this little line here. Okay, this blue line here. All right, and for angles, it gets a little bit tricky. So when a orange line, let's do it this way. So if orange line moves, let's say started from here and it moved all the way up here, right? The angle here is 90 degrees. All right, we say move 90 degrees if it moves straight up, starting from, be on top of this green line. If the orange moved straight up like this, then it moved 90 degrees. So that would mean this here is halfway, right? You see how this is halfway. This orange line is moved half the distance that this orange line moved here. See how it only moved up to this much, but here it moved up way more, right? So this is like half. So half of 49, half of 90 is 45. Okay, so this is about 45 degrees. So a little bit more would be 90. If I moved it straight up, if this orange line is pointing straight up, then it's 90 degrees. And notice how in this one I have a curve here, right at the corner. But for 90 degrees, you need to draw a kind of like a corner of a square here, okay, to represent that this is going 90 degrees, okay. And if I move the orange line even further, so let's say here's my green line. So let's say I moved the orange line all the way back here. So it started here, and then I moved all the way here, so that it's lined up with the green line, so it's making one straight line. So I can say that my orange line moved 180 degrees. All right. And if I moved it even further, so here's my green line. If I move my orange line even further back, so let's say it started here and I moved it all the way here. This angle here is another 90 degrees, so it's 260 degrees, okay? Sorry, no, it's not 260 degrees. Was it? 280 degrees. Okay, because 180 plus 180 plus another 90 degrees is 280, yeah. Not 270. Sorry. 270 degrees. All right, so yeah. So 90 plus 90, this is 180, and if I moved another 90 degrees, yeah, it would be 270. And all right, so let's say I have my orange line. Well, let's start the green line. So I have my green line here. Here's my orange line here. Let's say I completely move the orange line all the way around, okay? All the way around, and it stops at the green line. This would be 360 degrees. That's one complete turn, okay, or a complete turn. All right, so this is how we measure how much the angle of something, how much something has turned, okay? We do it with degrees, all right? Again, if you don't understand this, don't worry. I just want to kind of introduce it to you guys really quickly. All right, so we measure how much we measure the amount of space that two lines have met each other by degrees. All right. So one important thing you have to know is what an angle is. Okay, so this is the angle. All right. So we call this the angle. Okay, let me just gotta do some Photoshop stuff here. So this is an angle. Okay, this is an example of an angle. Call this an angle. So you don't need to worry about all this right here. And we know that when an angle is 90 degrees, we have to draw the special, instead of drawing this curve here, we have to draw this special kind of like a corner of a box at the base here, okay, to show that it's 90 degrees. This is a right angle, has a special name, right angle, which is a 90-degree angle. All right. So honestly, this is all stuff that I didn't start learning all this stuff until I was in high school. So if you're confused, don't worry about it. Okay. And another thing I have to teach you guys is, okay, draw some more angles here. Draw this angle here, draw another angle here. All right, so there's something called congruent angles. All right, congruent angles is pretty much when two angles are the same, we call them congruent angles. All right, when you see congruent, just think same. Okay, so if this was maybe 30 degrees, 30 degrees. Oh, all right. So since they both have the same angle, we call them congruent angles. Same angles. All right. Okay. Create some more space here. All right. Okay. So another thing you have to know is something called intersecting angles. Intersecting lines, sorry. Let's say I have a line here. I have a line here. And I have another line here. You see how they kind of crash into each other? At one point, they meet up here. Let's pick a different color. Let's do a yellow. You see how they meet up at this spot here? All right. This is called a intersecting lines. Okay, so intersecting lines are pretty much lines that cross each other, or they come across each other's path, or they kind of, yeah, they kind of crash into each other, okay? And they keep going, all right? So when two lines meet up and cross each other, intersect each other, they're called intersecting lines. And something that's the opposite of that. Here's a line here, and another line below it here. You see, I have two different lines here. Will these two lines ever meet each other? No, right? If these are both perfectly going, straight side to side, they will never, even if I stretch this on forever, never, 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 there would never be a point where they would ever intersect or touch each other. You see? Yeah, it would just be a straight line all the way, right? They will never, intersect or touch each other. Unlike these lines here, you see how at some point they do run into each other. So this type of lines that don't intersect or don't cross paths. Okay. These lines are called parallel lines. Parallel lines. Meaning these are lines that move next to each other, but they'll never cross paths, unlike this intersecting line here, okay? All right. Let's see. One more thing I need to explain to you guys. Here's the last thing. Okay, so let me try to explain this one. I have a line here, and I have another line here. There's two different lines. Okay. So you see how these two lines, I have a line going perfectly straight side to side, and I have a line that's going straight up. All right. This is called a this is called perpendicular. Sorry. Let's see. Perpendicular. So we say that two lines are perpendicular when they make a 90-degree angles or they make right angles. All right. This only happens if you have one line going straight side to side. You have another line going straight up. All right. This only happens when you have one line going side to side straight perfectly, and another line going straight up. Okay, just like this. All right. And since they make a 90-degree angle, we say that they are perpendicular. All right. Or two lines making 9 degrees angle. Okay. So would you say that, this line right here and this line? Okay. So are these two lines perpendicular? Is it making a 90-degree angle? Is this 90 degrees? So this is 90 degrees here, but is this 90 degrees? No. It's less than 90 degrees, right? Yeah. So this is not perpendicular because this here is not, this green line hasn't moved 90 degrees, exactly 90 degrees, okay? It would need to move straight up in order for it to be 90 degrees. Again, if you don't understand this, don't worry. All right. Okay, so I think that's pretty much all you need to know. Let's look at our math page. So let me zoom out just to show you all the stuff. Yeah. So there's all the stuff that we covered. A lot of things, right? I know it was a lot to, take in, but if you don't understand it, don't worry. Becca doesn't expect you to understand all this already. I think they just wanted to show you what some geometry questions look like. All right, so class practice, label. So pretty much really easy. They just want you to label what kind of line is this, okay? What is this? Is it an array, a line segment, an angle? What is it? All right, so look for the same picture. Obviously, yeah, if you just look for the same picture as this matches this, and this is a ray. So you just write ray here. Okay, so again, look for the dot and the models here, and then just write down what it's called next to it, okay? All right. Okay, number 2, write true or false in the blank. Okay, are these congruent angles? Are these congruent angles? If you don't know what congruent angle is, just go back to let's go up here, look for congruent angles. Okay, this is congruent angles, and they look like this. So does that look like that? Yep, looks like it. So just write true. Very simple. Okay, that's pretty much it. You just pretty much is matching pictures and words to what you see up here. All right, so it's not too difficult. Even if you don't understand everything I just taught, just let's just look at this. All right, for page 1. All right, next page. Okay, doesn't seem like there's anything new to go over. All right. Okay, again, yeah, so we've done these before. Don't let these letters mess you up, all right? If you don't remember this, then you can go back to my previous lesson on, working with unknown numbers and letters. So, okay, yeah, so for these, just remember to so you add first and then just drop the decimal point straight down. Okay, all right. Okay, so that's pretty much it. I hope you guys are doing well. If you have any questions, feel free to, email me, of course. Again, don't worry if you didn't understand this. I just wanted to, introduce you to some geometry concepts. All right, geometry is something you don't really dive in into until high school. So, okay, so that's pretty much it. Take care.